Hi, this is Chris, and we are taking a look at question 34 here in section 4 of this practice SAT, and you can download this with the link in the description below. So here we see that we have some exponents, and we have variables in our exponents. And that's actually a good thing, because there is an approach anytime you see this that you want to take. When you have variables in the exponents, you want to try to make your bases the same. And right now we have a base of 8 and a base of 4. And the first question that we want to ask ourselves is, can I find a number that I can take to a certain exponent to get 8 and to get 4? Is there a way that they could have a base in common? And hopefully, if we know at least a few of our exponents, you don't have to memorize everything. You shouldn't know 5 to the 11th off the top of your head. That's not necessary for SAT, but you should know at least your 2's probably up to 2 to the 5th or 2 to the 6th pretty comfortably without having to count it off. You should know your 3's up to maybe 3 to the 4th. Your 4's up to maybe 4 to the 3rd. Your 5's, you should know 5 to the 1st, 5 squared, 5 to the 3rd. So there are some that you should be at least somewhat familiar with. And here, hopefully, we look at this and we go, hey, wait a minute. I could take 2 to an exponent and get 8. What exponent would that be? Well, if we know our 2's well, that would be 2 to the 3rd power. And I could also take 2 to an exponent and get 4. That would be 2 to the 2nd power. And so if you're able to recognize that, that allows you to convert these into the same base. And once we do that, I'm going to rewrite this, and I'm going to show you why that's so important to solving these questions where you have variables in your exponents. So first instinct when you see variables in your exponents, make the bases the same. Once we do that, let's go ahead and rewrite this. This would be 2 to the 3rd to the 3x minus 1 equals 1 over, this would be 2 squared to the 3x minus 21. And when you have an exponent inside and outside of parentheses like we see here, you can multiply those. So if we multiply 3 times 3x minus 1, that would give us 2 to the 9x minus 3. When we distribute that, equals 1 over, and this would be 2 to the 6x minus 42 when we multiply that. Now, just like we would do in any situation, when we have a denominator that we're trying to simplify or trying to get rid of, we can multiply both sides times that denominator. You can multiply times 2 to the 6x minus 42 to move that to the left side of our equal sign. And so when we do that, we'll have 2 to the 9x minus 3 times 2 to the 6x minus 42. And if it helps to keep things organized, to put parentheses around those, you can. If you position it in an exponent positioning, then sometimes that's enough to be able to keep track of it. But just make sure you're careful, you don't get those numbers lost. And then here, when you're multiplying by the same base, so this is the second really fundamental skill that they're testing in this question. What do you do with your exponents when you're multiplying by the same base? And that's one of our exponent rules. If you had a squared times a to the 5th, for example, times the same base, you're going to add your exponents together. That would be 2 plus 5, which is 7. So this is just an example of the rule, and now we're going to apply that here. This would be the same thing as saying 2 to the 9x minus 3 plus 6x minus 42 equals 1. And for that to be true, there's another exponent rule that they're testing here, which is even if we maybe simplify things here a little bit and combine like terms, we would get 2 to the 15x minus 45, and it still equals 1. So our next exponent rule that they're testing on this question is that anything to equal 1, it has to have a very particular exponent, and that's going to be 0. Anything to the 0 power will equal 1. So as long as we know this as our second exponent rule that they're testing here, then we can set 15x minus 45 equal to 0 for that expression or for that equation to be true. add 45 to the other side, and divide by 15, we get x equals 3. So there's a lot going on here. We have to make the bases the same, and then we have to do some algebraic manipulation and apply a few different exponent rules to get this question right. But our first step before anything else is recognizing variables in these exponents and taking that first step to try to convert so that they have the same base. Stay tuned and we'll cover a few more questions from this same practice test.